This is another video with another 4 examples coming straight from your book, section 5.5 and 5.5a. And I have 4 examples here, these 2 and these 2. Okay? And the instructions are: write the expression as the logarithm of a single quantity. That means I don't want 2 expressions, I only want 1 expression involving the logs. And number 1 here is an example using natural log. And natural log is just a log with a base of e, the natural number e. And we use the same exact rules as we do for the common log. So don't be afraid when you see natural logs. Notice I have a number here in front of the log. That means this is the exponent of this argument. Okay, so let's do that as our first step. This is going to equal the natural log of x plus 1 squared minus the natural log of x plus 2. Now I have a difference of logs. That means I can use the quotient rule, where the numerator is the argument of the first log and the denominator is the argument of the second log. Second step, write it as a quotient and then simplify if possible. This doesn't simplify, so we're done. Okay, number 2, natural logs again. I have this natural log and I have this one. I have a 2 in front. That means I can place this 2 as the exponent here. So let's rewrite it with that exponent. Z minus 3 plus natural log of z plus 3 squared. And now I have a sum of natural logs. That means I can combine these arguments as a product. Z minus 3 times z plus 3 squared. And that's it. Okay? Example number 3. For example number 3, we have a number here in front of a log. Remember, this is the exponent of your argument by the power rule. So we have log base 5 of x plus 1 to the 1/3 power. And I can rewrite this as log base 5 of the cubed root of x plus 1. And that's it. Number 4, again, this one is pretty simple. I'm going to go about this one the long way, and then I'm going to show you a short way. Okay? Now, natural log of e, let me write this over here to the side, as we did with the other video. When we said that the log base b of b to the x power is equal to x, that also works with the natural log. So whenever I have a natural log of e, that is going to equal to whatever the exponent is. So in this case here, this expression is equal to 2. Okay? And 2 times 2 is 4, and 4 minus 2, this is going to equal 2. But let's suppose you didn't notice that. And so I showed you the short way first. That's the short way. Just knowing that this equals 2 and then multiplying that by 2, which makes 4 minus 2, 2. And that's your answer. If you don't notice that, this is what you can do. 2, this 2 is exponent of this argument. So this will be natural log of e squared raised to the second power. This second power was this 2 that you used as your power. Minus 2. Now I have to rewrite 2 as a natural log, and I just showed you how to do that. Natural log of e is equal to 1 because the exponent here is 1. So if you want it to be 2, you would multiply this times 2, which becomes the exponent in your e. So this here equals 2. That's how I rewrote this 2 as a natural log. And then I have a subtraction of logs, which means I can rewrite this as a quotient of logs, where the argument of the first natural log is my numerator, and this is e to the 4th power. And the argument of the second natural log is my denominator. This is equal e to the second power. And now I simplify. This is the natural log. E to the fourth power over e to the second power. That's the same thing as subtracting my exponents, which is e to the second power. And e to the second power is 2. Because whenever you have the natural log of e, it is going to equal the exponent of that argument. So there you have the long way where you turn this 2 into a natural log, or if you notice it from the beginning, this is 2 times 2 minus 2. Okay, so there you have both ways. My next video is going to be change of base formula. I'll see you in the next video.